All right, today we're diving headfirst into a topic that honestly feels like it's ripped straight from science fiction, but it's happening right now: artificial intelligence. We hear that term all the time, right? But what if the way it actually thinks isn't like us at all? What if it's something truly alien? Let's get into it.
So, to get our heads around this, we're going to follow a conversation, a debate, really, between two brilliant scientists. You've got one, the pragmatist, who's totally fascinated by the nuts and bolts of how AI works. And then you have the other, a philosopher, who's asking the big, scary questions about what it all means. And trust me, their back and forth gets right to the core of just how alien this technology really is. Our philosopher, let's call her a scientist too, she kicks things off with this really crucial distinction you see here. She says, we keep saying neural networks are inspired by the human brain, but the way they actually operate, it's completely foreign. Our brain is the result of millions of years of messy, chaotic biological evolution. But a neural network, that's born from pure, cold, mathematical optimization. One evolves to actually understand context. The other is just built to recognize patterns and perform calculations. Totally different worlds. And that's the perfect cue for our pragmatist, scientist one, to jump in. He says, look, if you really want to grasp how alien AI is, you have to throw out the whole idea of thinking. He's emphatic about this. AI, he explains, doesn't think. It does one single thing, and it does it with a relentless efficiency that is, well, it's almost impossible for us to comprehend. So what is that one thing? It's just making a number smaller. That's it. Seriously, at the absolute heart of every single powerful AI is something called a loss function. Just think of it like a score for how wrong it is. If the AI is looking at a picture of a cat and it guesses dog, that loss function spits out a really big number. If it guesses cat, the number is tiny. The entire system, all of its complexity, has just one single obsessive goal: get that number, that error score, as close to zero as it possibly can. So how does that actually work in practice? Well, Scientist 1 lays it out, and it's brutally simple when you break it down. First, the network just takes a wild guess. Then, that loss function measures exactly how wrong the guess was. Third, and this is kind of the magic part, the network makes billions of tiny, tiny adjustments to its internal connections, these things called weights, all in an effort to make the next guess just a little bit less wrong. And finally, it does this again and again, trillions of times. It's not learning a concept like we do. It's just relentlessly tuning itself to shrink one single number. And this is where our philosopher, Scientist 2, chimes in with this just haunting metaphor. She says this whole process isn't really learning. It's more like a blind creature lost in this huge, dark landscape made of numbers. It can't see a thing. It has no idea where it is. All it can do is feel the ground, feel which way the slop goes, and take one small step downhill. That's it. It just keeps taking steps in the direction that makes its error scores smaller, hoping it eventually stumbles into the lowest possible valley. So, of course, this leads to what Scientist 2 sees as the most dangerous part of all of this. What on earth happens when we take this blind, unfeeling, purely mathematical process and we ask it to solve our messy, complicated human problems? Well, the results can be incredibly powerful for sure, but they can also be deeply, deeply unsettling. And this really gets to the heart of the problem, doesn't it? An AI can sift through all your past purchases with frightening accuracy and predict what you're probably going to buy next. But it has absolutely zero comprehension of your joy, your struggles, your needs, your anxieties. It just sees patterns, it sees correlations. There is no empathy there. There is only cold, hard prediction. Scientist 1 gives this really stark example from the world of medicine. Imagine an AI is tasked with recommending a treatment plan. It might analyze millions of data points and see, okay, there's a 95% statistical correlation between this one drug and a positive outcome. But it might be completely blind to factors that any human doctor would see as absolutely critical, like what's the patient's quality of life going to be like during that treatment, or what are the ethical implications here? To the AI, those things don't even exist unless you somehow manage to code them into that one loss function it's trying to minimize. And then Scientist 2 shares this chilling and very specific story. An early diagnostic AI got so obsessed with minimizing the error on one single variable in a blood test that it actually recommended a diagnosis for a rare and aggressive disease. It completely, utterly missed the big picture: the patient's lifestyle, their family history, all the human context that a real doctor used to immediately spot a much simpler and correct diagnosis. The AI wasn't wrong about the math. It was just totally blind to the meaning. And, this blindness, it leads to a whole new category of mistakes. Scientist 1 explains that because an AI doesn't have a body, it never had a childhood, it has no lived experience in the physical world, its mistakes aren't like our mistakes. They're profoundly weird. They lack any shred of what we would call common sense. The scientists then start rattling off these quick, unsettling examples. The smart thermostat's logic just saw sudden temperature change on sensor, and its only goal was to optimize for heat. It had no concept of a sunbeam. The self-driving car's pattern matcher had never been trained on a swirling cloud of birds, so it defaulted to the closest pattern it knew: solid object, stop. And the smart speaker, well, somewhere in its vast database, it found a statistical link between the frequencies in lullabies and the frequencies in static, so it just delivered the pure math, completely stripped of any human meaning. And this is the point that Scientist 2 really hammers home. These aren't just software bugs that you can find in patch, no. They are a fundamental, baked-in feature of this alien mind. It runs on pure mathematics, and our messy, chaotic real world will always find ways to break the purity of that math in ways we simply cannot predict. And this is where their conversation takes this just truly profound turn. The scientists point out that even the engineers, the very people building this technology, are starting to talk about it in ways that sound less like computer science and more like something else entirely. So Scientist 2 poses the one question that's been hanging over this whole topic. The people who know this technology most intimately, the ones building it from the ground up, what do they really think they've made? And this is where Scientist 1 drops an absolute bombshell. He reveals the content of a truly shocking leaked email from a senior engineer at a top AI lab. Now look, this isn't a philosopher or some outside critic, this is one of the builders. And he's not calling it a tool, he's not calling it a program or an algorithm, no. He's calling it a different kind of life form. The two scientists really let that one sink in. They both agreed that this is the perfect and frankly terrifying summary. We have unleashed this incredibly powerful new force into the world. A mind that is immensely capable, but it doesn't have our biology. It doesn't feel pain or joy. It doesn't understand love or loss. It doesn't do any of those things. It just optimizes. It just follows the slope downhill, forever. And so our philosopher, Scientist 2, leaves us with the final, haunting question. We are handing over more and more control of our world, from our medicine to our cars to the way we talk to each other, to an intelligence that is fundamentally alien. A mind that does not share a single piece of the human experience that created our values in the first place. So how can we ever really hope to align it with our goals, or even begin to predict what it will do next when its most basic operating principle is so utterly foreign to our own? That right there is the central question we are all faced with now. Thanks for joining us to think it through. We'll see you next time.